Hello everyone, it's me. Don't be afraid. I'm just wearing a mask because I'm not wearing any makeup. And if I go outside, I just like to take precautions. I'm totally safe, no fever, nothing. Okay, we're just taking precautions here. But today you're going to learn how to encrypt a message. Like you want to send a special message, encrypt it because you don't want anybody else to know. How do you do that? Well, you'll get a chance to learn that today. Are you ready? So let's start encrypting a message. So let's move on to here. Oh, yeah, welcome to my neighborhood to encrypt a message. I'm going to set this up. Alright, here we go. Okay. Now, how do you encrypt the message, right? Now, obviously, this has something to do with 8.3, and you know that 8.3 had to do with inverses. You know you're going to need 8.3 matrix inverse here, okay? And so far, you've been practicing AX equals B. And do you remember how you multiply the inverse on both sides? Left side, right? A inverse A equals A inverse B. This becomes the identity matrix, so X equals A inverse B. Whatever this product is, that is your X, right? Well, encrypting a message has something to do with that. Also, you're going to also need this for your next activity that's coming up, and where you write your friends a secret message. Okay? Now, a couple of things. We have to set a couple of things. Okay? So let's let A. This is the most basic. Obviously, the CIA isn't using this technique. I mean, if they let A equals B, B equals 2, what do you think C is going to equal? 3. You're right. And D is going to equal 4, etc. You getting the point? So that means in the end, Z is going to equal 26 because there's 26 letters in the alphabet. And obviously, the CIA isn't using this format, but we will in this class, okay? Yeah, you don't want to get too complicated just yet, okay? But if you want to get creative, you can set this for your friends so we know what to do. Now, once you've set this alphabet by numbers, you also need like some punctuation, right? So how about a period, right? Like a period, you could make 27. You could make exclamation marks, and maybe that's 28. Maybe you could make spaces, like empty space. Maybe you could make empty space be 0, okay? You can set all this however you want to, okay? Alright, once you've done that, we can start encrypting messages. Okay, so let's start that, okay? I'm going to give you the 1, 2, 3 in encrypting a message, okay? Now, first thing you're going to have to do is decide on, for example, I set some criteria here. 1 through 26 is A through Z. The space is 28 in this case, and the exclamation maker is 27. We're going to encrypt a special message called KELLY. Ooh, okay? And you know who that is? That's Miss Chang, okay? Now, of course, you're not really going to make Kelly, but you're going to make more interesting message for yourself. But I'm going to teach you how I would encrypt Kelly. First thing you should do is write Kelly. So first, you're going to write your unencrypted matrix, which is going to be your A. Unencrypted matrix, what does that mean? That means the one that spells out Kelly. So think about it. Common sense. Do you think you actually give your friends this unencrypted matrix to unencrypt or decode? Of course not. This is the one you start with though. So first step, unencrypted matrix, A. Now we can decide on what size matrix you want, depending on your encoding matrix, which we're going to talk about, okay? Now let's say I'm going to spell out Kelly in this way. I'm going to start out Kelly by creating 11, 5, 12, 12, 25, 27. What does this mean? KELLY. And 27 is the space. Okay? So Kelly. And it's a 3 by 2 matrix. So what that means is this is the original message. This is your secret message. So obviously you don't give it to anybody, okay? But you have to start here so you can tell your friend, hey, decode my message. So again, first step is to write an unencrypted matrix of any order that you like. And now, whatever your matrix your A is, your X is going to be your encoding matrix. That means your X has to be able to be multiplicable to your 3 by 2 matrix in this case. So, next step, step 2, encoding matrix, your X. Your encoding matrix is the one that you want people to use to actually decode your message. And you can make that up however you want to, okay? So in this case, I made up an x that's a 2 by 2. Now as you can see, I can multiply a and x because it's a 2 by 2, a 3 by 2, and a 2 by 2, right? So that's a good thing. And I just wrote a 1, 2, 3, 4. But the only thing is this has to be a non-singular matrix. So it needs to have an inverse, okay? All right, non-singular matrix, okay? Now, again, you're going to give your buddy, so wait, do you get it? Step 1, unencrypted matrix, you don't give to your friend. Encoding matrix, your friend needs to. You have to give it to the decoder in order for them to use it to multiply. So you have to give this up and you have to make it up. And most importantly, it has to be non-singular. Non-singular. So it has to have an inverse. So let's check. 4, 6, not a 0, right? So that's a non-singular matrix. Because 1 times 4, 2 times 3, 4 minus 6 is negative 2, and that means it's a non-singular matrix, okay? So again, first step, start with your encrypted message. Start with your original message. Write it into a matrix, and you don't give it to your person. But the encoding matrix, you definitely give to your decoder, okay? Because you're going to need it to solve. Last step is your third, encrypted matrix. This is what you give to your friend. And this is essentially your B. What does that mean? That means you multiply A and X. And you multiply A and X. You multiply your A and X. What do you produce? Right? You produce B. You produce the product B. In my case, I multiplied my A and my X, and I got this product. And this is what you give to your friend, because this is what you want to tell your friend without getting caught, right? But you don't want anybody else to know what the special message is. So you give this to them. You give them, so 2 things you give your decoder. You give them this X encoding matrix. You gave them 3, the unencrypted matrix. And what do you do with it? Here's what you do with it. So, here we go. We're going to unencrypt Kelly, okay? So, let's go back to our original. Remember that it's our, right? It's our A, X equals B. Some cases it's A times C equals E. It's the same shit, okay? It's the same shit. But our A, okay, this is your first step. Second and third. Give, okay? So what do you do? So your person is going to get this, and your decoder is going to get this. What do they do with it? All they do is they do this. A, X inverse equals B, X inverse. So in our case, this was a 2 by 3 matrix, right? Or was it a 3 by 2? It was a 3 by 2 matrix, right? And our X was a 2 by 2 matrix. This was and then we get this, right? What should we get? We should get a 2 by 3 by 2. And this guy's a 2 by 2. So we multiply that, we actually get, if we do this, we're going to get this A back. Okay? So let's try that. So my encoding matrix, so I'm going to take my B, which was my product of A and X. So which was the product of my A and X, I'm going to show you that. My A was this, my X was this, but my B was this. So I take my B and I multiply by inverse of A. Okay? So I'm going to take you can take your calculators, okay? So what you do is, I'm going to multiply my B. My B was 26, 48, 106, 42, 72, 158. Okay, that's my B matrix. I got the B by multiplying my original and my encoding matrix. Okay, original and my unencrypted matrix and my encoding matrix. All right, and I multiply that with my inverse of my X. So I'm going to write the original X, which is 1, 2, 3, my encoding matrix. But in my calculator, I'm going to write that it's the inverse. And when you do that, what should you get? You should definitely get Kelly. You should definitely get 11, 12, 25 here. Of course, you made it this way, though. K-E-L-L-Y, and then a space for 27. Okay, and then you have to decide, you have to tell your decoder what special formula you want them to use. That means K equals 11, 5 equals E, 12 equals L, 12 equals L, 25 equals Y. So then they go, oh my god! I figured it out! It's Kelly! Oh, not a space, not an exclamation mark. Kelly and a space. That's what you're gonna do, okay? Good luck on your decoding, and you're gonna be practicing this skill more and more, and then eventually writing your own in the activity that's coming up, okay? Good luck, everyone! See you soon!